Hi, I'm Charles. I'm a doctor of pharmacy. I've had a broad education in all the sciences and mathematics. I've taken a lot of math courses. As a matter of fact, I had the top math score in my calculus class one time. But it's not because I'm really great at math, it's because I enjoy playing with numbers. And this is my email, by the way, if you want to get in contact with me. If you have any questions about what I'm about to present to you today about dark matter or Big Bang. Big Bang or dark matter, it's a growth sequence. I'm using the times 10 to the 0 numbers. That's the numbers 1 through 9. I don't need to use the numbers 10 through 99. That's the 10 to the 1 numbers, etc. to get 99.99% of the original elements of the universe. I just need to use 1 through 9. And I do it using doubling sequences, and there's only 4 of them. And not only are there doubling sequences, but they're related to dimensional changes as well. I have 1 to 2, 2 to 4, 4 to 8, and 3 to 6. Now 3 to 6 is out of phase with the main doubling sequence. This is my 4th dimension. Now to get to 2, you can go 1 plus 1 is 2, or 2 times 1 is 2. To get to 4, you can go 2 plus 2 is 4, or 2 times 2 is 4. When you start using multiplication, you start dealing with dimensions. But what I do is I put all of this together, all of these numbers. These are all doubling sequences. I put them all together and multiply them, and I get what I call as Big Bang or dark matter. And I'm going to show that to you in just a minute. So it is equal to 1 times 2 times 3 times 4 times 6 times 8. And it's a very resilient number because it can also be written this way. 1 to the 0 power, or 1, times 2 to the first power, times 3 squared, times 4 cubed. And it can be also written as 2 times 24 squared. This is a dimensional change I'll get to at the end of my presentation. You'll see that. Since 2 is such an important number in our universe, I like to write Big Bang in terms of 2's. So I have 2 to the 0, or 1, times 2 to the 1, which is 2. And then in parentheses, I have 2 to the 0 plus 2 to the 1. That's 3, times 2 squared. And then again in parentheses, 2 to the 1 plus 2 squared. That's 6, times 2 cubed is 8. This is dark matter, and you're going to see why I arrive at that conclusion. Before I go on any further, I want to eliminate some of these numbers from 1 to 9. 0, well, that's nothing. That doesn't really get you anywhere. And as a matter of fact, to get 99.99% of the original elements of the universe, I don't need any of these numbers, so why would I want to use them? 5 is 2 to the 0 plus 2 squared. It skips 2 to the first power, so that's quite a jump. It's not, I wouldn't consider that a normal doubling sequence. 9's even a farther jump. It's 2 to the 0 plus 2 cubed. It skips 2 to the first and 2 to the second power. And 7 would have to be 2 to the 0 plus 2 to the first plus 2 squared. And that's not likely either. The periodic table uses 5 and 9, and I can arrive at Big Bang using these numbers, but I get a much larger table and more complicated one, and I don't need to do that. So I take 5 and 9 out of the periodic table, which is a factor of 45. I recalibrate. Here's your table that produces 99.99% of the original elements of the universe. I'm going to assign hydrogen the mass number 24. Everything's relative as long as you keep it relative. 3 quarks equals a proton or a neutron, and currently science has 360 assigned to the mass of a quark. If you divide that by 45, or 9 times 5, you get 8, and that's just what I have here. And look at all the 8s here. This is quark. These are quarks here, down here. And 8 times 3 are 3 quarks, makes a proton, which is a mass of hydrogen. And then that's 24. That's what I've assigned to hydrogen. That's the main element in your universe. After hydrogen comes helium. That's 24 times 4. There it is. It's 96. Now we have some heavy hydrogens where you add in neutrons on board. Deuterium is double the mass of hydrogen. That's 48. There's 48 again. And tritium is triple the mass of hydrogen. It's right there. Here's helium again. Now, these are important factors here. These are your main factors. How I got them was I said, well, 2 times this number will give you Big Bang, and 3 times this number will give you Big Bang, and 4 times this number will give you Big Bang. I don't use 5. 6 times this number will give you Big Bang. I don't use 7. 8 times 144 gives you 1152. I don't use 9. I don't use those numbers I told you about. These numbers I got by factoring out of these numbers here. 192 times 3 gives you this. 144 times 4 gives you this. 96 times 6 gives you this. Another example. 48 times 6 gives you this. I don't have to factor this way. I don't have to say what 3 times the number will be to give me this, or I'm just getting duplicate numbers. So what you have is an upside down triangle factor table. And right now, I've already listed over 99% of the original elements of the universe already. Carbon is 24 times 12. That's carbon. Oxygen is 24 times 16. That's oxygen. So we've got oxygen, we have carbon. These are your quarks down here. Out of this number you can derive hydrogen and helium. You have to kind of combine them to get your hydrogen and helium universe, your quark universe, your carbon universe, your oxygen universe. Up here, this is a Big Bang. I'll get to that in just a minute. Let me list the other elements that make up the 99.99% of the original universe. You remember when I was adding the 2's together with Big Bang, I added like 2 to the 0 plus 2 to the 1, for instance. Well, you can add these numbers too. This table has both multiplication and addition properties. Argon is 40 times the mass of hydrogen, 40 times 24, and that equals 576 plus 384. And you can do the same thing with silicon, neon, and nitrogen. Here's an example of neon. Neon is 20 times the mass of hydrogen, and it's 192 plus 288. It's this number plus this number. And nitrogen is 192 plus 144. And sulfur is 32 times the mass of hydrogen. That's this number times 2. Magnesium is this number times 2. So right there, other than iron, iron actually goes above Big Bang because that's probably not part of the original universe. It probably came from a star exploding because it's Big Bang plus 192. But that right there covers 99.99% of the elements of the universe. And so that begs the question, you know, if I've assigned all these numbers right here to elements, I've assigned these numbers to elements, that begs the question, what is this? Well, this here is what all the other elements strive to become, are what creates all the other elements. It's Big Bang. It's the mystery of the universe. And how do you get to it? You extrapolate. I could say 3 times oxygen equals this number or that number. That's ozone. Or I have a better candidate. I have 4 times 288, or 4 carbons will give you Big Bang. That's what I've decided Big Bang is. That's what I'm putting to the test. You can decide for yourself. I'll show you a picture of it here. I don't know if I showed you this table. I'll just go over it again real quick. This is hydrogen is 24, a quark is 8, a helium is 96, deuterium is 48, tritium is 72, carbon is 288, oxygen is 384, and that's 99.5% of the universe right there. But here's Big Bang. Here's your 4 carbons. It's a 4-carbon ring structure. Carbon bonds 4 times. It bonds 2 to this carbon and 2 times to this carbon. This carbon binds 2 times to this carbon and 2 times to that carbon. You don't see this in chemistry books because no one ever figured it exists that way because the angles are really tight. But there's a dimension change when you get to Big Bang. That's what allows this to be what it is. Let me go over this dimensional change with you. Now, when I mentioned the oxygen universe and the carbon universe and the quark universe and the hydrogen and helium universe, they all fit into the format of 12 squared times 2 cubed. But we have a dimensional change when we go to 576, or 24 squared, times 2 to the 1. You see, we go from 12 squared, 12 times 12, 12 times 12. See, we have to add them all together. We have to add 4 of them together to get 24 squared, 24 by 24. This is your dimensional change. This is what allows you to have Big Bang, the 4 carbon ring structure right here. You lose space in the process because space just flattened out. It went from 2 cubed to 2. So it got pancaked and producing Big Bang. So what we do is we use these elements over here to create Big Bang. Or you can go the other way. Big Bang creates all these other elements. I mean, you can go whichever way you want, but still, this is Big Bang right here. I like to look at these dimensions a little more closely. 12 squared, that's a planar dimension. In a macrocosmic scale, that would be the rings of Saturn. 2 cubed, that's your orb, that's your planet. And they interact with each other. 12 squared for me is 3 to 6. That's your doubling sequence 3 to 6. And the rings of Saturn, that's 2 cubed. That's the doubling sequence 1 to 2 to 4 to 8. And then this sequence interacts with this out of phase sequence to give you 4 dimensions. My 4 dimensions are different than Einstein's space 3-dimension scenario. Your 4 dimensions are your 4 doubling sequences from 1 to 9. It's as simple as that. So what we have is we have space contraction if we go this direction, but we do have expansion of the plane. So we're rotating around a universe that's flattened out. If you look at a macro model instead of a micro model. And it makes perfect sense. Now all the numbers I've shown you, you can't disagree with them. 1 plus 1 is 2. There's absolutely no way you can disagree with this chart, the way I developed it. This is Big Bang. This is 1 times 2 times 3 times 4 times 6 times 8. I factored it out. I left out 5, 7, and 9. You don't need that. And I got your elements of the universe right there. There's no denying it. I like to see you try and deny this.